Hello students, my name is Theodros. I'm a physics teacher. Today we'll start Unit 4 of grade 11, that is dynamics. First, let us see the concept of force. What do I mean by force? Force is something that can change the speed and direction of a moving body. That means that can change the velocity of an object, or that can make an acceleration, as well as what? Changing the shape of a body. That means that can deform the shape of a body. Actually, to deform the shape of any body, we must exert at least two forces. One force can cause the object to accelerate. And there are four basic forces in nature. The first one is gravity, and the second one is electromagnetism. That means the attractive and repulsive force between magnets and charged particles. The third one is nuclear force. We have two types of nuclear force: weak nuclear, and the fourth one is strong nuclear force. These are the four basic forces in nature. We have one example here. A boy is pulling some box at an angle theta, and this boy is exerting a force in two dimensions. The first one is to pull up the object in the vertical direction, and the other one is to pull horizontally the object, which is the horizontal component. Therefore, in this case, to pull the object, which force is applicable? Only the horizontal force is applicable, or the horizontal force is responsible for the movement of the box. Therefore, we must resolve the horizontal and the vertical component of the force by using the vector concept. That is, vertical component in the y, that means the vertical one is equal to the applied force times sin theta, and the horizontal one is equal to the applied force times cos theta. By using this technique, you can resolve 40, 50, then the vertical component is 50 Newton times sine 40, and the horizontal component is 50 Newton times what? Cos 40. You can see here. And the other thing is basic laws of dynamics. The basic laws of dynamics is Newton's laws. We have three laws of Newton's first, second, and third law. According to Newton's first law, always, if there is an external force acting on an object, if the object is at rest, it remains at rest. Or if the object is in uniform motion, that means moving with constant velocity, the object will move with that velocity. That means it will not accelerate until an external force is acting on an object. And the second law states that if there is an external force, the object will what? Accelerate. And the acceleration of the body is always towards what? The direction of the net force. Therefore, it's expressed in the form of F is equal to mass times acceleration. And the third law is action reaction force. And when we exert a force on a body, the body will exert an equal force on the exerting object in opposite direction. This one is Newton's third law. Let us see friction. Friction is divided into two: static and kinetic friction. And static friction is a frictional force when an object is not moving. The frictional force type when an object is at rest is static friction. Always static friction is greater than the kinetic frictional force, as well as the coefficient. Force of static is always greater than force of kinetic. And also coefficient of static is also greater than coefficient of kinetic friction. This is obvious. And the maximum amount of static friction, that means if the object is at rest, it is static, and when you move, or when the object is start to move, before it's starting, it has still what? Static friction. And that maximum amount of static friction is named as limiting friction. And to calculate static friction, you can apply that frictional force of static is equal to coefficient of static times normal force. Fn is the normal force. Sometimes it is Fn, or sometimes symbolized by N only. We have one example here. A box of weight is 60 Newton on a ramp which is uninclined at 30 degrees to the horizontal. The box is limiting equilibrium, that means it's stationary. Find the coefficient of friction between the box and the plane. First, we must find the normal force. Here 30 degrees, therefore this one is how much? 30 also. Therefore this one is mg sine, no, mg cos 30 degree. This one is equivalent to the normal force. Mg mass is how much? The box is weight is 60 Newton, therefore 60 cos theta is the normal force. And then the limiting equilibrium, you must first find this. Cos 30 is radical 3 over 2 or 0.6, and then this one is equal to mu s times Fn is equal to 60 sine 30 degree, and substituting this, the Fn or the normal force is 60 times cos 30, and it's cancel out, and finally you can get how much? 0.58 value. Therefore this one is not cos, this one is what? Sine. No, this one is, yeah, cos, it's right. But here F net, or no, since it is in stationary, the downward force is F times what? Sine theta, and the upward force is Fs. Therefore Fs is given, Fs is cosine of 30 degree, and you can apply this. And finally you can get the coefficient of friction of 0.58. The maximum value of coefficient of friction is below 1. Therefore the frictional value or the coefficient of friction is between 0 and 1. And the other one is kinetic friction. Kinetic friction is a frictional force when an object is in motion. And always when the speed of the object is increasing, always the coefficient of friction is decreasing. When an object is moving with high speed, the frictional force is always decreasing. Therefore speed and frictional force have an inverse relation. Therefore when the speed of an object is increasing, the frictional force of the body is always what? Decreasing. That's why a car moving with high speed is difficult to stop at small distance or at short time. The other thing is Newton's and gravity. We have seen this on Unit 3, at the end of Unit 3, that is Newton's law of universal gravitation states that between two celestial bodies there is what? An attraction force, and this attraction force is depend or directly proportional with the product of the mass, and it has an inverse square relationship with what? The separation distance. And he cancels out the proportionality and writes a constant that is g. G is gravitational constant, and which is equivalent to what? 6.67 times 10 to the power of 11 minus 11. The third point is the law of conservation of linear momentum. When we say conserved, it's what? Unchanged. The initial and the final value is what? Constant. Always momentum p is calculated by what? Mass times velocity. If there is no an external force acting on an object, the change in momentum of any body is equivalent to what? 0. That means momentum before or initial is equivalent to what? Momentum final of the object. This is obvious if there is what? External force. If there is no external force, therefore in the absence of external force, the momentum of the body is constant. But if there is an external force, the object will accelerate. That means change in momentum if F net is different from 0, change in momentum is also what? Different from 0. That means if F net is different from 0, this indicates that there is what? An external force. If there is an external force, the momentum of the system is not conserved. The other thing is the law of conservation of linear momentum. We have seen this, and let us see one example. Two rods are perpendicular to meet at a junction. Car A is with this mass and moving with this velocity due north, and car B is with this mass and moving with this velocity. And at the junction, the cars collide and move together. We said what? It moves together. Therefore, the final velocity of the two cars is what? Similar. And write down the initial velocity of the car before collision in vector form. Before collision, north is in the y-axis, positive y, and south is negative y-axis, and east is what? Positive x, and west is negative. Therefore, car A is 0 and 20. 0 and 20. That means in the x-axis 0, in the y-axis 20, and car B is in the x-axis 60, in the y-axis what? 0. And in B, find the velocity of the car after collision. Before collision, first you find the moment of this car and this car separately. The momentum of the first car A, has a mass times V, mass 1, V1, or mass A, VA plus, mass 2, V2, or mass B, VB. Mass A or mass 1 is 1000 and VA or V1 is this value. Therefore, you must take the product, and for the second also, you must take the product. Therefore, when you multiply this, you can get 0 to 20,000, and multiplying this, it's around some value, 20,800, and this one is 0. Therefore, combining these two, you must add x with x and y with y. Finally, you get the initial momentum this much. And after collision, they move what? Together. That means the final velocity of the two cars is similar. Therefore, after collision, MA V plus MB V is equal to P after. Therefore, V is similar. Therefore, you can take V as a common. MA plus MB is equal to what? P after. And then MA is 10, MB is this much times V is substituted. And finally, you get out 2300 V times kilogram. And this value and this value is what? Equivalent. You make these two equivalent, and finally you get this much value for the final velocity. The other thing is impulse. Impulse is when you change the momentum of an object, or if impulse indicate that, or impulse is equal to what? Changing momentum of an object. And Newton's second law is also expressed in terms of changing momentum over what? Changing time. And if you make it crisscross, changing momentum is equal to what? F net times what? Changing t. Therefore, impulse is equal to changing momentum, or impulse is equal to what? Net force times changing time. Therefore, this is the impulse equation. Therefore, impulse is changing momentum. There is one example here. Do this by yourself. Let us see another example. Elastic and inelastic. Another point, elastic and inelastic collision in 1 and 2 dimensions. When we say elastic collision, if the collision is elastic collision, if the kinetic energy of the system is what? Conserved. If not, it's what? Inelastic collision. Therefore, elastic collision is a collision where kinetic energy is conserved. Inelastic collision is a collision when a kinetic energy is not conserved. But in both cases, the momentum of the system is conserved. The momentum is conserved in both cases, inelastic as well as elastic collision. But if it is elastic, the kinetic energy is conserved. If it is inelastic, the kinetic energy is not conserved. The other thing is glancing and head-on collision. Glancing collision is a collision in what? 2 dimensions, and head-on is a collision in 1 dimension. When we say glancing collision, it's 2-dimensional. When we say head-on collision, it's what? 1-dimensional collision. This question is also already done. Therefore, try to see by yourself these 2 questions. Let us see center of mass of a body. You have learned about center of mass on grade 10. Now, how we can find the center of mass of a point? Let us see that. Let us see by an example. Look at the figure below. The 2 masses are balanced. What is the distance of the 2.5 kilogram from the balancing point? From this to this is how much? 2 meters, and we have this much mass. And from this to this is unknown. It's x, and this much mass. Therefore, if it is balanced, the turning effect of this object is equivalent to the turning effect of this object. Therefore, let us say this one is torque 1 and this one is what? Torque 2. Torque 1 and torque 2. And this one is what? Anti-clockwise. Since it is anti-clockwise, it's what? Negative. And the clockwise direction is what? Positive. Therefore, T1 we make negative because of what? It's anti-clockwise. And finally, we get the sum of the 2 torques is equivalent to what? 0. because it's balanced. Torque 1 is equal to torque 2. And the product of this minus 2 times what? 1.5 times 9.8 is equivalent to this 9.8 is gravity, because we take the weight. Weight is equal to mass times gravity. Let us take, or let us make 10 is equal to, for this, x times what? 2.5 times 10. For this one becomes 50 times 2 minus 30 is equal to what? This one 25x, and divide by 25 by 25. Finally you get x is equal to some value, and the minus sign is only for the direction, that means clockwise and anti-clockwise direction. Okay, do this example by yourself, but to find, as a general equation, to find the weight, the center of mass of an object, we must use two basic equations. To find if it is two-dimensional, to find the x and y center of mass, you must apply this equation. Mass of 1 times what? x1. That means from the axis of rotation, this x or distance is always measured from axis of rotation up to the mass. For example, if it is such a like material, and if we have 4 masses in such a like, and if this one is the center of mass, the distance, let us say this one is m1, m2, m3, and m4. When we say x center of mass, you must only consider x-axis values. Therefore, for this, x2 is equal to how much? 0, because it's on the axis of rotation. You put this in xy direction by making at the center the axis of rotation. Therefore, the x value is unchanged. Therefore, x2 is 0. x3 is from this up to this. Let us say this one is 5. Therefore, from this up to this is 5, as well as, since we are taking the x value only at this point, the x value is how much? 5. And x4 is also at 5. And x1 is 0 because it's at the origin. By taking these assumptions or this technique, you can determine the center of mass of an object, x center of mass and y center of mass, and finally, when you express the answer, center of mass of a body is equal to x center of mass, comma, y center of mass. And the other thing is momentum conservation in variable mass system. In variable mass system, we will consider two variable mass systems. The first one is rocket, the second one is rail. In rocket, the flame that is out from the rocket reduces the mass. Therefore, we will take what? Change in m. This change in m is reduction in mass. Per time. Change in m is reduced mass per second. The exhausted mass per second is change in m. Therefore, by taking this, for a rocket, since it is reducing in mass, the acceleration of the rocket is increasing. Therefore, the applied force or the starting force F plus u times change in m is equal to what? Mass times acceleration. This equation is used for decrease in mass situation. And u is the exhausting gas speed. And if it is rain, the inverse is true. You must subtract. That means this plus sign is changed to what? Minus. That means F minus what? U change in m is equal to what? M times A. Because here we have over change in t. Sorry. Here also we have in the equation we have here change in time. Here we have also change in time. There is change in time because change in m over change in time, that is reducing mass per second. Therefore, because we make minus in the rain case, it's not decrease in mass, it is increase in mass. The water droplet moves down, and the mass of the water is increasing. Therefore, since it is increase in mass, you must use this equation, and by moving this to the right, you can rearrange as F is equal to ma plus u times change in m over change in t. You can take such a like. And also for variable mass system, if you take an explosion, always in the explosion case, the initial momentum or the momentum before explosion is always what? 0. Therefore, when you did such examples, momentum after collision is equivalent to 0. This is your starting point. Therefore, for example, a 1 kilogram object explodes and breaks into 3 pieces. One piece has a mass of this much and this velocity, and the second piece mass this and this velocity. What is the velocity of the third piece? Since it is 1 kilogram, the first one is what? 400, and the third one is this much, the second one is this much, and the third one is the sum of these two when it is subtracted for 1 kilogram. Therefore, the sum of these two is 650. 1000 minus 650, m3 is equal to how much? 350 gram. Therefore, the first one is 400 gram, that means 0.4, moving with this speed, plus the second one is this much, 0.25 times moving with this speed, plus the third one is 350, that is 0.35 times xy, unknown speed, is equal to what? 0. This one is momentum after is equal to 0, because the momentum before collision is 0. And momentum after is equal to momentum before. If momentum before is 0, the after must be also at 0. And by arranging, finally, you can get the value of x and y. For this equation, the value of x and y is this much. That means the value of the third piece is minus 35 in the x direction and 4.3 in the y direction. Okay, dynamics of circular motion. When a car going around a bend, there is a force toward the center of the circle that keeps the car moving in an arc of a circle around the bend. This force is provides the friction between the tires and the cars in the road. Therefore, one way reducing the force needed to keep the moving in a circle bank is the track race, using the principle and constructing roads also banking to make them safer. Therefore, this is for the normal force. For such diagrams, for the normal force, we will take what? The weight, because it's straight. And for the centripetal force, which makes the object to be in a circular motion, is the frictional force. Which one? The static friction. Therefore, Fs is mu s times Fn. Therefore, Fn is mg. Therefore, Fs becomes what? Fs becomes mu s times mg. And mg, from mg, we can rewrite this, the centripetal force, which keeps the object is the static friction, and this one is equivalent to the centripetal force. Mu s mg is equivalent to what? Mv square over r, and m is cancelled by m, and mu s times gravity is equal to what? V square over r, and also v is expressed as omega square times r. Therefore, mu s g is equal to what? Omega square r square over r is cancelled by r. Mu s times g is equal to what? Omega square times r. And rearranging this, mu s is equal to what? Omega square r over what? G. And substituting the whole values, you can get the static friction value of what? 0.11. There is one example. This example is easy, and try to do by yourself. The final answer is also given and the steps are also listed. Therefore, do it by yourself. Until next time, this is all about today. Until next time, have a nice time.